This short video tackles the problem of how any unbalanced rotary thruster can accelerate without using the centrifugal force concept, but, instead, the inertial resistance to acceleration, stated in the first law of motion, and the inertial confrontation concept, described in videos of this channel, in which the inertial tendencies of two bodies are in conflict, in a dynamic process that constitutes the mechanism underlying the third law of motion. In the model used as illustration, when the two bodies suddenly start rotating, their centers of mass manifest the tendency to move in straight paths. Focusing attention on the tendency of the main body to start moving in the straight path defined at the start of the rotational cycle, a conflict is established with the inertial resistance of the container structure or vehicle. The inertial resistance of the structure or vehicle to accelerate forward acts upon the main body as a centripetal force to cause its acceleration backwards, bending its path towards a circle around the center of rotation. Knowing that the inertial resistance of the center of mass of the main body increases with the increase of its rotational speed, the resulting inertial confrontation varies with the rotational speed. Therefore, the operational frequency, given by the sequential clockwise and anti-clockwise rotations per second. When the rotational speed is very low, the inertial resistance of the vehicle is able to cause the bending of the paths of the centers of mass of the main body and the secondary, backwards, closer to the circle around the center of rotation. Increasing the rotational speed, the inertial resistance of the rotating bodies to the bending of their paths, backwards, causes a forward acceleration of the vehicle. With a higher rotational speed, the path of the secondary can reach its straight path defined at the start of the cycle, defining its maximum contribution to the forward acceleration of the vehicle. A further increase of the rotational speed increases the inertial resistance of the main body to the bending of its path, backwards, increasing the forward acceleration of the secondary and the vehicle. At very high rotational speeds, the inertial resistance of the center of mass of the main body can be high enough to cause a forward acceleration of the secondary and the vehicle, so that its curved path can approach its straight path defined at the start of the rotational cycle. The speed that allows the center of mass of the main body to move along its straight path, defined at the start of the cycle, establishes the maximum acceleration of the system. The main body requires an appropriate configuration to restrict its interaction forces with the secondary, without effect upon the center of rotation. Therefore, a means to synchronize its motion with the secondary is required. For this task, an intermediary arm is added to connect the main body to the gearbox, with an appropriate design to avoid interference on the interaction between the main body and the secondary.